our family traditions at this time of year is the big clear up. There's a time limit on our tolerance for the accumulated junk, the temporary displacement of furniture to make space for Christmas trees, decorations, cards, and mountains of discarded wrapping paper, piles of new toys, all those other festive fripperies. At a certain point, Twelfth Night, it's good of them to mark it out on the calendar, some kind of alarm switch trips, and it's a case of loading up the car to transport the rubbish to the refuse tip, where we quickly discover we are not alone. Everyone else has the same idea. Queue, long wait, in a queue. Now, when I teach about searching for innovation opportunities, one of the great tools to introduce is find a queue. It builds on a well-established principle of lean thinking. Most of the times, the presence of a queue means that value isn't being added somewhere. Something or someone is being forced to wait for something to happen, and that's a waste of time, of space, of energy, and so on. So there's an opportunity to think about how to change the process, to innovate, to smooth out the bottleneck. Find a queue, do a process map, and begin the innovation journey. So, sitting in the queue for a refuse tip started me thinking about the innovation opportunities that so much accumulated waste might have to offer. And whilst it might be possible to improve the ways and speed with which families can be separated from their rubbish, the real benefits are buried a little deeper. In fact, it's worth referring back to a well-known piece of Yorkshire wisdom. Where there's muck, there's brass. Where there's rubbish, there's financial opportunity. Waste needn't be a problem to be hidden away, buried, or burnt to get rid of it. Instead, there are real opportunities in waste, as plenty of innovators have already found out. Think, for example, of Earl Tupper, whose efforts to turn the black sludge emerging from the 1940s oil refineries paid off when he created the bright, shiny plastic kitchenware which still bears his name, Tupperware. Or Charles Goodyear, who managed to improve the unpromising raw material of rubber with its tendency to become sticky and brittle into something elastic and flexible through the vulcanization process that he literally cooked up in his kitchen sink. Or Henry Ford, who developed a plastic made from soybeans and used that to make car parts, demonstrating an early example of how you could use agricultural waste to create valuable products. And of course, this is still happening. Take the case of a company called TerraCycle, founded in 2001 by Tom Zaki as a business specializing in recycling and upcycling various waste materials. Envar is a UK company which recycles coffee grounds into biofuel, an approach which has been deployed elsewhere. Virgin Atlantic picked up some very helpful publicity and valuable learning when it flew an Airbus from London to New York on November the 28th last year, using a diet of 100% biofuel, essentially derived from waste cooking oil. In doing so, they scored a notable PR bonus, being the first of many airlines to be seen to be doing something to help reduce their climate impact. Adidas has been doing something else similar for the fashion industry. Their partnership with Parley for the Oceans creates shoes and apparel from ocean plastic waste. And Nike, not to be left out, has been running its Grind program since the 1990s, turning waste from shoe manufacturing into surfaces for sports facilities, and once again, manufacturing waste to valuable products. In fact, there's growing interest in using waste as a feedstock for further use, through recycling or reusing it in different forms. And waste tips are increasingly seen not as dumps, but as mines, full of valuable resources which can be dug out. It's a useful analogy. Think about gold mining, and the traditional picture is something like a hot, cramped shaft a mile below Johannesburg's city streets. The results of long, sweated hours are brought to the surface and end up mostly as huge piles of rock which are painstakingly separated to yield a few grams of gold. That's not so far from what is now becoming commercially interesting, digging deep into waste heaps to extract and concentrate small flecks of gold or many other valuable minerals from the piles of discarded electrical goods. When I took a tour of my local waste processing facility recently, I have so much fun in my holidays, I had a growing sense of déjà vu. Where had I seen something like this before? Separating out an unpromising feedstock of unpleasant smelling raw material into different parts which could be further refined to produce something of value. And then it struck me, an oil refinery. The processes might be different, think physical separation instead of fractional distillation, but the underlying story is the same. Identify the value in different streams, find clients who will pay for it, and manage the business accordingly. And it's a profitable business, so much so that councils and local authorities are increasingly selling the licenses to process waste. Recent reports suggest profit margins for this sector at between 30 and 60%, which suggests it's worth taking a close look. That global recycling industry is worth about $400 billion and is forecast to grow at over 5% a year, at least for the next 10 years. A recent 2023 McKinsey report offers an optimistic scenario for plastics recycling, for example, suggesting a future in which 50% of plastics worldwide could be reused or recycled by 2030. Now, following that path, plastics reuse and recycling could generate profit growth of as much as $60 billion for the petrochemicals and plastics sector, which is representing nearly 2/3 of its possible profit pool over the period. Now, of course, it might not be so easy as waving the magic wand. There's widespread concern that plastics recycling is much more difficult to achieve because in practice we have the challenge of separation. Most plastic waste is mixed and contaminated. But while manual separation may be cheap at the moment, it's being supplanted by a new generation of smart sensors and actuators. CES 2024 might have some glamorous consumer products and plenty of AI on the front stage, but behind the scenes, there's huge improvements in the sensor and actuator field, which could drive the cost of separation down whilst improving its efficiency. And it's not just economic pressure in the marketplace. Increasingly, regulation is pushing for higher rates of recycling and for manufacturers to take responsibility for their products over the whole life cycle, which is promoting some ambitious innovation in recycling. Henry Ford's ghost might enjoy a trip to the southwest of England, where the Charles Trent scrapyard in the town of Poole has quietly reinvented itself as one of Europe's most advanced de-production facilities. It's cost over £10 million so far, and at first sight looks like a car assembly plant, except that this one is focused on disassembly. Whole cars go in at one end, and their skeletal remains emerge at the other. Around 96.3% is reused or recycled by weight. That's way above the 95% legal target and the UK average, which is around 93% or yes. Part of what makes that model work is the emphasis on separating out the valuable but harder to get at elements rather than simply recycling steel for scrap. On a typical day, 120 cars arrive on trucks from all around the area, and engineers crawl all over them, attaching barcodes which identify key valuable items. It's a high-tech operation. Robot arms lift things clear so humans can get in with cutting torches. Barcodes labeling and tracking everything. Wheels, batteries and tires, they're the first things to be removed. Many, they can simply be refurbished and resold. Others can go to specialist recycling. Fluids are drained off, fuel, oil, even water, and they're used in the company's own vehicles. And then the carcass of the car is hoisted onto a disassembly line, where it visits 4 stations. Each one, the barcodes are scanned to identify what has to be done and deliver instructions on how to deal with the different parts. It's got a lot in common with Henry Ford's old lines, the same race to complete tasks against the clock, for example. 15 minutes is allowed for each set of instructions. The stations are specialized. Station number 1 deals with doors, panels and interiors. Number 2 with lights and dashboards. Number 3 with moving parts like engines, gearboxes, axles and catalytic converters. And the last stage is electricals. Engine blocks are washed, labeled and reassessed for whether they can be reused or simply stripped down for parts. What's left after all of this is to crush the rest into a metal bale and send that to the scrap recycler. The whole process takes about 60 minutes and handles 75 cars a day. Now, a key element in the process is the downstream platform where the parts are sold online. eBay has become the UK's largest retailer of car parts, and it's preferred not least because it offers guarantees of provenance and quality. It's grown as a marketplace partly because since the Brexit split from the EU, spare parts are becoming scarce. Prices have risen and consumers and repairers are prepared to pay and reuse recycled ones, especially if they come with a guarantee. So the approach is not only greener, but also up to 70% cheaper. And innovation's continuing to help develop the process further. As the CEO of the company comments, within the next couple of years, our target will be to close that recycling loop to nearly 100%. That's the future of car recycling. So innovation in processes is a key, but so too is innovation in the underlying ways we think about it and how we frame business opportunity, business model innovation. Now, current concerns around the availability and the complex geopolitics of key raw materials is promoting a rethink and a re-evaluation of opportunities. Key minerals like lithium or cobalt are going to be critical, and the search is already on for alternative sources of supply. So how about remining as one route forward? In another recent article in the New Scientist, Graham Lawton reports on thinking and the technology development behind it, which is looking at revisiting coal waste as a source of valuable raw materials. A recent webinar hosted by the US National Academies of Science, Engineering and Medicine explored some fascinating options which revalued thousands of sites of old coal mines which are littered with unsightly waste heaps. Now, there's a lot of collateral waste associated with coal mines, slag heaps, ash ponds, and so on, and they don't make for green and pleasant landscapes. They're mostly the consequence of burning coal, but they might represent a rich source of opportunity. Burning coal concentrates residual chemicals in the rock, and those residuals include some of the most sought-after minerals in today's world. Lithium is close to the top of the list, essential for our current electromobility revolution and the batteries which will drive it. But there are other members of the so-called dynamic dozen of key strategic materials which are present on those slag heaps. Estimates suggest that US coal waste alone contains nearly 300,000 tons of lithium, enough to supply the US market for 130 years. Plus, those waste tips also contain other high-value materials: cobalt, think mobile phones, platinum, iridium, gallium, and germanium. Semiconductors, anyone? Rethinking waste in this way takes not only money, it also needs that classic entrepreneurial skill of reframing. Seeing what others don't see. At its core, this trash to cash business model is all about reimagining waste as a valuable resource. It requires an open mindset, but also a long-term vision. The changes which might make such a business model viable may take time to materialize. But somewhere in that future of uncertainty about resource availability, concern for pollution, and an increasingly strong regulatory framework lie the seeds of significant opportunity. There's also a need to think big and recognize that this kind of change will require a rethink at the system level. Much of the circular economy argument hinges around this theme of bringing together different players to create something viable, which has emergent properties. The whole is greater than the sum of the parts. Now, sustainability-led innovation is, at one level, easy and obvious. Only a very short-sighted organization would fail to try to do what it does better. Saving energy, reducing carbon footprint, whatever. It's a no-brainer. And there's scope for the visionaries who see that this might also be a route to new products and services, a way of creating a company or of renewing and transforming an existing one. The role model of Ray Anderson, who took Interface Flooring from being a small carpets company to a major player in the industry through committing wholeheartedly to the sustainability vision, it's a powerful one. But the big challenge in sustainability-led innovation is going to be working at the next level up, the system level, assembling and aligning multiple players into a coherent ecosystem. And that's going to take a lot of entrepreneurial vision, reframing, and dogged perseverance. But the prize may be worth it. In earlier centuries, alchemists were seen as the somewhat lunatic fringe, with their attempts to transmute base material into gold. With today's technological, political, and economic environment, we may be closer to reaching that goal. To paraphrase a classic one-liner from those Hollywood depictions of the California gold rush, "There's gold in them there hills," could become "There's gold in them there landfills."